also go over an example where we have two binomial terms not being multiplied, being added or subtracted, and how we would approach a situation like that. So up on our whiteboard here, we have an example. So given to us in this example is 2x minus 3 multiplied by 4x plus 1. Now, in a scenario like this, this whole expression, or this whole term, 2x minus 3, is being multiplied with this whole term, 4x plus 1. So if we can imagine that 2x minus 3 represents some sort of variable a, and 4x plus 1 represents some other variable b, this expression should technically give us a result ab. Now what this means is we don't just have to ignore the fact that there's a negative or a positive. These terms need to multiply in a way to generate a result ab for us. Now, we can extend our idea on that, and we're going to start multiplying these two binomial expressions. The first multiplication can start between the 2x and the 4x. So we just multiply. Now if you remember from your previous years that whenever you're multiplying a variable by a similar variable, these variables would be raised according to the power. Now if you notice, the 2x has no exponent. When it's like that, it means that it has an exponent of 1. The same thing with the 4x, it has an exponent of 1. If we're multiplying two terms and they each have the same variable, then we'll write the variable, and what happens with the exponent will add. So we have 1 and we have 1. Because there's multiplication between them, these exponents add to give you 2. Now, this covers the variable, but there's a 2 here and there's a 4, which is a real number. So then we'll take the 2 and we'll multiply it with the 4. So 2 times 4 is going to be 8. So that gives us 8x squared. But that doesn't finish our multiplication. We need to continue. The 2x also multiplies with the 1. So the 2x times 1 is going to give us 2x, but we have to realize that there's a plus sign here. So we're going to put a plus sign, and then we're going to multiply the 2x with the 1 to give us 2x. Now we've taken care of this first term, multiplying with those two. We're going to now take care of this negative 3, and again follow the same process. It's going to multiply with the other two terms. So we start off with negative 3. Let's change the color for now. Negative 3 multiplies with the 4x. Since the negative 3 doesn't have a variable, and the 4x has one variable x, the x variable will remain the way it is, but the negative 3 will multiply with the real number 4. So negative 3 times 4 gives us negative 12. And don't forget, we have an x, so negative 12x. The negative 3 then also multiplies with the 1. These are two real numbers. Negative 3 multiplies with 1 gives you negative 3. We can expand, which we have done. We can simplify now our term. So simplification happens between like terms. That's the whole idea of simplifying an expression, is that we're collecting like terms. So we look at our first term. It's 8x squared. Now in order for expressions that or terms that have variables to add with one another, they would have to have the same variable and with the same degree, or exponent. In this case, 8x squared, there's no other term here that has an x to raise to the power of 2, so we can't continue with simplifying this with any other term, so we'll just write here 8x squared. We're also going to be going and looking at the next variable x, but in this case it has a degree of 1. So both of these have a degree of 1. We find that it's 2x minus 12x. So now the variable stays x, and 2x minus 12x, you just treat that as regular subtraction, like a 2 minus 12, and your answer would be negative 10x. So that leaves us then with our last term is minus 3. Okay. Now, this covers the solution for this binomial being multiplied with another binomial, and multiplication is involved. We expanded using a system. The system, probably learned it. It's called FOIL. So first, out, in, last. You can use FOIL. You can multiply the first term with the first term with the second term with the first, the second term with the second, and expand, and then you simplify your terms with the simple expression. So our answer is 8x squared minus 10x minus 3. We're going to go in and we'll try a different example. So in this example, I'm going to combine both multiplication and addition between the binomials. So we'll start off with an example 4x minus 2 plus 6y plus 3 plus y squared. So if you notice, we're not multiplying two binomials together, like in the previous example, but we do have real numbers in front of each parentheses. Now again, if you, in the back of your mind, or like if you want to like think about this term here can be represented by a variable a. This can be represented by a variable b. This then looks similar to a situation of multiplying the 4 with the a to give you 4a. And this term here multiplies with this binomial to give you something 6b plus y squared. So we're going to take the 4 and we're going to expand and multiply with the binomial. You start off with the 4 and it multiplies with the x. 4x. Then you multiply the 4 with the minus 2. 4 times negative 2 gives you negative 8. And that's done. I have a plus. We're going to put a plus sign here. Now let's start with the 6. The 6 multiplies, again, distributes with the y to give you 6y. The 6 multiplies with the 3 to give you plus 18 plus y squared. Now we have to collect like terms. So by collecting like terms, we have to start, usually you start with the variable with the highest exponent. So in this case, we'll start with y squared. There's no other term that has y to the power of 2. This is our only term, so we're going to write this here. We don't have any other term to combine it with, so we'll just write y squared. The next variable we will deal with is y. So 6y to the power of 1. There's no other term there that can add with 6y, so we'll just put here plus 6y. Next variable is x. There's no other term that has an x, so it will, we'll just add it here, plus 4x. And then our final two terms are negative 8 and plus 18. These are both real numbers, and we can add them together. So negative 8 plus 18 is the same thing as saying 18 minus 8, so we're going to put plus 10. And now we have resulted in a simplified expression. We've expanded and we simplified the expression. So in both these examples we looked at multiplying binomials with each other, and expanding multiplying, and then afterwards we simplified terms by either subtracting like terms or adding like terms, and we're giving a resulting expression, simplified expression. And in the second example, we multiplied the binomial with the real number, and the binomials themselves were not being multiplied with each other, they were being added with each other. So basically it's a simpler process. We expand the real number, and then we collect like terms and simplify. Thank you very much. And if you have any questions, if you have any concerns, or you just need a little bit more support or insight about how to expand binomials and simplify them, you can always send an email to my inbox.